So this is going to seem like it's cookie cutter because I laid out steps. So you have steps to solve this problem. And the hardest part is actually just reading the words. You talk about reading the words about in the sections. It's also hard to read the words when they're describing a word problem because the way that your book does it is they tell you a scenario or story. And they're doing that because they're trying their hardest to make it a real problem that you can read about and go, oh, this is like, you can visualize that scenario. But that also makes it so that if you're looking for information, reading out that information that you need to solve the problem is a little bit harder because you have to dig it out of the words. So let me see. Go to. Sorry, that was like for instructors. Like, let me find where I start.
This is the true step one.
Hang on, don't take notes yet. Okay, here we go. Okay, start here. All right, because there's before step one, there's this part. So how do you do this part efficiently? You have to read the words. So I don't have it in front of me, but this is out of section 5.1, which is your reading, I think, for next week. But this is why there's different tips you got in class, like go to the review questions for the check on reading. Somebody else said they need to do different things. Like I know as a student what I would do, I would go to the quiz questions first and then go to the reading second. Everybody's got their way, but I think if you really want to get the deepest amount of learning that is better long-term would be to go to the actual problems, the actual case study problems first. Because if you can see how it's used in one of these examples, then all the reading will make much more sense. I think that might take a little longer time at the beginning, but as you go through, it's going to be a lot easier. These are your givens. This is not my given, so I don't have anything that I'm doing. I'm just reading. And I call it reading with my pencil. So literally, my class notes look like this. Not just my class notes, but if I ever did something for real, I would read like this. I read with my pencil and I jot down notes. And what's interesting to me is the course leadership on that homework problem did the same thing. I think that's how you, like that, if we're very different kinds of people. So if we're doing the same thing, that must be the way to go. You take down information from the written parts. I kind of know that students focus on numbers. I do too. So I focus on the numbers. Every kind of numerical data they give me, I jot it down. I use those as anchor points, and I jot that information down, and I tell myself, what is this? So I don't try to like formulate anything. I'm just taking the information down. So a lot of students blow past this, and they think they're just like, I got to get the equations. I got to get the equations. Don't do that, because you're going to save yourself time if you do this. And if you don't believe me, my sister didn't like math, and she actually was taking class, and I asked her, why were you like not doing this? Because she had 4 problems on a test, midterm and final, that's it. And so she would like blow past all of this and try to get the equation and get it all wrong, and then she'd get no points. And so I asked her, well, you started here, you're supposed to start here. She goes, well, it takes too long, and I'm being timed. And I said, let's put a stopwatch on. We're gonna go. Ready, set, go. I'm gonna do it my way, you do it your way. I did it my way. I finished first. I got the right answer. She did it her way. She finished second, and she got the wrong answer. And I said, I think my way is actually shorter, because she was backtracking all the time, trying to figure out like, where do I like? I'm trying to write the equation. Where do I do this? Where do I like? So she's backtracking, and her backpedaling cost her more time, and got her the wrong answer in the end. So that's my plug to you. Do this, because I'm not lying to you. Like I already told you, like where to cut corners. This is not one of them. So in this story, there's a company, they have 2 products, an 8-foot glass door and a double hung wood frame window, whatever. They're trying to have these 2 products. And they have 3 plants that are making the ingredients for this product. I had to figure that out by reading it. So I'm blowing past all the like time I spent just kind of reading it. Plant 1 produces aluminum frames, and plant 2 produces wood frames, and plant 3. So they're giving me some information about how this is going to be done. Where do the new products get made? Well, I read this, and these are the notes I made. What was interesting is when the team read it and that are teaching this class, some people read that you could use different plants. No. To make the glass door, you need stuff from plant 1 and plant 3. And it says and in the book. So I had and here. And the windows needs plant 2 and 3. And Callan, you mentioned several times it's hard to read. Like this is my synopsis, but there was a lot of words around this. Like they tell you, oh, there's a CEO and he wants two new products. And the data team comes in. So there's like a story to it. So you can read this out of the story.
I don't mean like the case study for each, but like when it's just like discussing I guess like the topics, like discussing the topics, it just goes on forever.
But the case study, when you're trying to solve a problem,
That's fine.
all of that is noise around like taking the information out, right? So if like you care that the CEO is doing all this stuff and that he called the data team and that they have 4 people in the data team, like irrelevant, has nothing to do with anything. You're just trying to like get the information out. So you have to kind of filter that and put the important things. And then I wrote what are the decisions they're trying to make. That's the prescriptive thing. What are they trying to do? They're trying to figure out should the company launch the products at all, and what number of each product should be produced per week. And then they on page 198 they have like a long discussion. And so I kind of, just to be honest with you, I kind of like skimmed that discussion. I was on the hunt for what's important for me to solve this problem.
So far you have your given stuff, and then
Some of it, right? Yes. So I'm just taking notes on this stuff, and I have to because there's a lot of words around it.
So for the given part, what were you saying the rubric for that? Because we had prep last year, and it was kind of like you give them like the actual what's it called, numbers, and then there's like some that are like it's in the text, but it's not numbers. You know what I'm saying? It's like I don't know how to describe or like example right now, but like
the givens here, like the things you have to figure out are the decision model. That's the slider, like the sample size. It's the same thing. You have to figure out like what it is you're trying to give a quantity for. And then in this case, it's 2 things. What number of each product do I have to give? And then you have to figure out what it is you're trying to optimize. In this case, they're trying to maximize profit. So like step 1 you can change these around if you want to. This is not like an order. Like whatever you find are the constraints, you can label them out. I put a time point on like how much time it took me to get to this part. Like it takes some time to do it, to figure it out if it's that massive amount of words that you have to read through and filter and find these things. So I did that, and then the constraints are like the sample size, like thing. Like I do have some constraints. I'm not allowed to do whatever I want. I can't have 1 million people in. Same thing, like there's going to be constraints. They can't just make millions things of the product. So there's going to be some constraints on that. And they give you the constraints.
we go back to that.
Yeah. Thank you. So I think it's the way I do this is I go through the numbers that are given in the problem. I try to identify and explain what each one of these numbers are telling me. And then I go to like, can I from there tell you what I'm trying to optimize? Can I from those words tell it? Yeah, they say it. They want to optimize. Obviously, as a company, they want to optimize and maximize their profits. So that one was easy. But the formulaic constraints, I had to go dip back down in the words and figure out what their constraints are. Let me know when you're done. And I'll throw these slides in all their glory into your instructor packet, like the folders. Okay. So what would be the constraint? Well, I'm reading this word problem, 30 minutes it took me to kind of read the whole thing and take these things out. But it's understandable that at each of these plants, they can't just make millions of doors and glass windows or whatever they want to do.
Like there's constraints on how much labor it's going to take to like what they can produce. Just like the MRI that's up at Keller. There's a certain amount of limitations of how many cadets you can measure every day because there's so many cadets coming out. That thing's running 24 hours, but there's a limit. There's a band on what they can do. Same thing. So that's what's going on. And so I jotted down some notes. These are my legit notes. Like I literally went in the book and wrote these notes. If you ever come down to my office, you're going to say, how can this lady be so neat on her math and so chaotic everywhere else? This is like the same. Any math person writes like this when it comes to writing out math. Do you want to write this down? These are just my notes from the word problem. It's still trying to decipher what they're telling you. That's going to be your hardest part, is going to the word problem and just deciphering that information. And it takes me time. It's going to take you time. I do recommend taking notes. There's actually studies that show that if you take notes, you learn it better. So you're here anyways. You're forced to be here, or you want to be here because this is like the best class ever.
Whoa.
Okay, so they have other numbers in here. So these are my constraints. I'm like labeling out. Plant 1's available for 4 hours a week. That also tells me my units per week profit that we're going to estimate things on. Plant 2 can give 12 hours per week. Plant 3 is available 18 hours a week. Each door requires 1 hour of time in plant 1 and 3 hours of time in plant 3. Each window, like they have a table, table 5.1. I saw that you're given sometimes this table. To me, the table is not helpful because I don't have any context of where these numbers are coming in. Are they part of the constraints? How do I set them up? I don't know that by just looking at a table. So I actually ignored the table. I just was trying to read and say, how do I come up with the constraints? These to me look like constraints. It's just like the MRI. The MRI can only be used a certain amount of time. I'm trying to think of other things like this, but like you have limits on what you can do as a plant. I always say good mathematicians that like they might think they're smarter than everybody else, but actually what we are good at is we're really incredibly patient, and we have the audacity to think that we can solve any problem that's given to us. Those are the two things that make a good mathematician. Patience. Number one is patience. Isn't it weird that the act of writing, all of you are writing the same thing that's on this slide, but the act of writing actually helps you learn better. It's weird. It doesn't make sense to me, but. Okay, any questions on this? I'm trying to tell you what it felt like reading that problem. So it's, like you said, the case study might be easier to read, but weeding out this information from it is a little bit, it's a challenge. Now that the data is ready, we can formulate this into a mathematical model. This is the transform stage. So again, in a real life problem, they're trying to make it real life for you, but really they're condensing it like 1 hour of Law and Order with commercials. They're trying to like give you that experience, but packaged into 1 hour. Well, that's not reality, but the reality is I have to like, usually even with people I work with, I have to talk to them quite a bit to get an idea of what it is they're trying to do. Just like the FNIH thing I showed you. So how do you formulate this algebraic model? Step 1, you have to define your variables. Rubric, that's why they have the rubric there. So it's not in the book. I just wrote it out. Like, that's what I would do. Like, what is it I don't know? In the problem that I showed you the other day, it was like, how many patients should I enroll in this study? Now I have a variable. So to me, like, this problem would not be a problem if they knew how many doors and windows they had to make. So, and I knew that the units had to be weak because everything else was given to me as per week, right? Sometimes people get tangled up with calories per day. Like, if everything is recorded as calories per day, then your units are calories per day. So I'm looking for these units, and I'm super, super hyper neat about this because nobody
they used to try to tangle students up a few years ago, and I remember they changed the units here, and see if you noticed that you changed the units to day and then you had to convert it to week. I won't be stuck there. Like, I'm not going to make that mistake because I immediately, my eyes are looking for this. For how are they like bulking up their time? And then constraints are the next steps. X is the number of doors per week it produces. It takes 1 hour. 1 hour per door times the number of doors has to be less than 4. And I make sure the units actually work out in my head. I'm looking at this is 1 hour per door total times the number of doors. The doors will cancel unless it's hours, and 4 is the number of hours.
What would like a constraint to you for the like arrow type of functions?
I don't know. I don't remember. Yeah, I'll have to go back and look. I don't know if there was a constraint like that. That was like a baby problem.
It wasn't really constrained. Your assumption was that the sun was
It
not.
was assumption, yeah. So it was more like your homework than it was this. This is like the full shebang of what you're going after, right? Like we're ahead like several lessons. You asked for it. You guys asked for it. Are you regretting it? I'm nervous because every other class is doing something different today.
Well, I was just wondering because I want to get smart off like how I do my problems. I do my problems a little differently. Like I do like how it makes sense. Like right out. I identify my variables first. That's what I do.
So on these problems, they're complex enough that I don't know what the variables are to start with until I read it, especially if they have a lot of words around it. If you have the book with you, if you took the book and brought it with you, go to section 5.1. You'll see what I'm talking. I'll flash it up here if you want to see it. It's like 3 pages of words, right? So like I couldn't look at it and then figure out how to like put the variables on there. So I did it for once I figured out one of them, I realized every one of them. Plant 2's restriction, plant 3's restriction. Plant 3 can make doors and windows, and plant 3, it can use 3 out. This is how many doors can be made per hour at plant 3, and this is how many windows can be made per hour at plant 3, and then sum those up. And that has to be smaller than or equal to 18 because they only have 18 hours of labor possible. And I always think about the negative answers now. I didn't when I was a kid. I would always get these I was never that kid, the student that actually had perfect grades because I'd forget something like this. But now I think about it. I'm grown up and I could kick butt in those classes now if I took it again. But here, you're supposed to also think can my answers be negative? Number of doors, number of windows can't be negative. So these constraints are usually inequalities. The constraint with the FNIH problem I gave you would be you can't have negative number of people. You can think of constraints, right? You can't have negative costs. Those things will be positive.
For this, I generally call still 2 inequalities, which feel I don't know together, and make -2, -12, and then cancel it out so you find the y.
So, do you remember, probably, did you guys take exams to, SATs, you recently took SATs, right? SATs. When you took those exams, do you remember drawing regions? If you mapped this out, it would make a region on the XY plane. And then you had to shade in that region. So that's what's going to happen. You have this region. The constraints make this region. And on that region is where you're actually looking at optimization. It's just like the sample size question again. You really have constraints that set up a region of possibilities.
You're not trying to get it.
No, not yet. That's why you can't just go, I got my variables. It's a bigger problem. It's more complex than that. Then I need to formulate the objective function, which is what you're trying to maximize. So there's nuts and bolts to it. You have a decision model. The objective function, which is what you're trying to optimize. And the constraints. So where you just had an algebra word problem, you know, Jose has nickels and dimes in his pockets and he has this much money and then he has this many coins. Tell us the number of nickels and dimes that he has. Those problems, you can go straight down to the unknowns and label them right away. You can't here. It's more complicated. So this is called a linear programming problem because everything's linear. That's all defined in your book. The terminology will be low-hanging fruit to ask for questions. All right, so I'm going to show you what this the full formulation looks like this. This is what you're trying to maximize. It's linear. Your x and y's are like sliders. I can slide these things around, and I'm looking for that sweet spot of combinations of x's and y's that will give me the maximum value for p over this constrained region. That's what you're looking for. But that's the full formulation, algebraic formulation. You don't have to solve it. They're not going to show you how to solve it. They just want you to set this up. And then you're going to use Excel to solve it. Right. So you could also, like, what I call the sliders, and I actually thought this weekend, if I had time, I'm going to make a little slider tool for you so you can see it. I can actually slide the number of x's and y's around. So I can start out like I could have 0 doors and y windows, or like 5 windows. I could have 5 doors and 0 windows. So I can have these combinations of windows and doors, and I can slide them around and look at what's my profit now? Am I still in the right region? Have I still satisfied that? So you slide those things around until you get to that sweet answer where you're going to get maximized profit. That's what you're going to be doing. Does that make sense? Does that help with the reading? I'm surprised. It surprises me. And I have all the definitions here. Sure. And, I'm going to dump it into your folder, but if you want to take a picture and keep it together, you can. This is where we're going. This is where we're going. Like the sample size question is exactly this question. What's my decision variable for the sample size question? Yeah, what's the decision variable? How many people for the study? So I could have 0 people, 1 people. Like you can slide that. That's your decision variables are your sliders. And then what's the constraints? Budget is your constraints. What are you trying to maximize? Not profit. You don't get anything. The maximum amount of people under these constraints. There you go.
How long did it take to solve a problem? It says like 30 minutes, 15 minutes, like per part, like how far deep is the problem?
This was just the reading. So it was like a cooked problem that was in the reading. So how much time it took me to read and decipher it, I put those timestamps on here. Because I wanted people to know that if they are a first-time teacher that it takes me time as well as it takes them time. Like it does take time to read. If you have a lot of words, you have to like pinpoint. And I'm like fast. I'll go through and try to find the numbers. I'll do anything. I'm a weasel. I'll try anything I can to make less time for me. Not as complicated as this. I think this was as maximally complicated as it could be. But you're going to have to read, like this is the problem that they have as your example. Every section is going to do this example. And they're going to know that you have done that example too, like worked it through. So I would say go read 5.1 so you get what I'm trying to tell you, that there was a lot of words behind it.